Day 9, the quadratic formula. Today we will be able to derive and use the quadratic formula. The quadratic formula, the process of completing the square, can be used to solve ax squared plus bx plus c equals 0 for a formula. This famous formula can be used to solve any quadratic equation. It is called the quadratic formula. The quadratic formula, if ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we actually have a song to help you memorize this formula. Let's sing it now. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So take a minute and pause your video and practice singing the song. Example number 1. Solve the following quadratic equation. So when we solve the quadratic equation using the quadratic formula, the first thing we want to do is make sure it's in standard form. So this quadratic, 2x squared plus 5x plus 1, is in standard form. Step number 2 is to identify our a, our b, and our c. So looking at this, I know that a is equal to 2, b is equal to positive 5, pay attention to the signs in front, and c is equal to 1. After you identify your a, your b, and your c, you are going to plug it into the formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So when we simplify this, we want to follow our order of operations. So we're going to simplify what's underneath our radical first. So we get x is equal to negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times 2 is negative 8 times 1 is negative 8 all over 2 times 2. X is equal to negative 5 plus or minus 25 minus 8 is 17. And then we can multiply the 2 times the 2 on the bottom and get 4. So we want to check to make sure that our radical, so square root of 17, is simplified using our perfect roots before we finish and say this is the answer. Is there a perfect root that goes into 17? Nope. So we are finished and we just solved a quadratic equation using the quadratic formula. So as we just saw, the solution to many of these quadratic equations are very complicated expressions. So let's practice simplifying a few of them. Example number 2 says 8 plus or minus the square root of 32 over 6. So the first thing that we want to simplify is your radical. Can we simplify the square root of 32? You're going to use your perfect squares to simplify a radical. So in class previously, we asked ourselves, what perfect square goes into 32? So when we look at our list of perfect squares, we know that 32 is between 25 and 36. It is not divisible by 25, but it is divisible by 16. So we can rewrite the square root of 32 as the square root of 16 times the square root of 2. We know that the square root of 16 is 4. The square root of 2 cannot be simplified further because there's no perfect roots that go into it. However, when we simplify this further, we need to look and see this special triangle right here. All three of those numbers, so first of all, it must form a triangle. So you must have 3 numbers with 3 numbers to simplify. when you're simplifying that, they all must be divisible by the same thing. So 8, 4, and 6 are all divisible by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. Your square root of 2, or your radical, you don't ever touch. And 6 divided by 2 is 3. So our two solutions to our quadratic is 4 plus 2 square root 2 over 3. And then we have 4 minus 2 square root 2 over 3. So let's simplify another one. Negative 4 plus or minus the square root of 36 over 2. So the first thing that I look at is my radical. Negative 4 plus or minus all over 2, the square root of 36 is 6. So then you can go ahead and write your two answers. You must have two answers. So we have negative 4 plus 6 divided by 2. And we have negative 4 minus 6 divided by 2. So x is going to equal both of these. So negative 4 plus 6 is 2 divided by 2. Negative 4 minus 6 is negative 10 divided by 2. So we get x is equal to 1 and x is equal to negative 5. So our solutions are negative 5 and 1. So let's solve the following equation using the quadratic equation. The very first thing we need to do is make sure it's in standard form. So standard form, remember, is ax squared plus bx plus c. So if we add the 1 by using the inverse operation, we get 2x squared minus 4x plus 1 is equal to 0. We then, step 2 is to identify our a, our b, and our c. So looking at our equation, we know our a is 2, our b is negative 4, and our c is positive 1. Step number 3 is to plug it into the formula. X equals negative b. Because our b is negative, we want to go ahead and put that negative 4 in parentheses, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We then want to simplify further. A negative and a negative make a positive 4 plus or minus the square root. Negative 4 squared is positive 16. Negative 4 times 2 is negative 8 times 1 is negative 8. All over 2 times 2 is 4. So we have 4 plus or minus the square root of 16 minus 8 is 8. All over 4. We're going to take it over here to continue simplifying. The square root of 8, so we have x is equal to 4 plus or minus the square root of 8 can be rewritten as the square root of 4, square root of 2. The square root of 4 is 2, square root of 2 over 4. We then want to make our triangle. Can we simplify this any further? Yes, they're all divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Do not do anything to what's underneath your radical. 4 divided by 2 is 2. And you just solved this quadratic equation. One of our solutions is 2 plus radical 2 divided by 2. And one of our solutions is 2 minus radical 2 divided by 2. You can now complete your worksheet.